Now that we've got some of the basics of pedigrees underfoot, let's have a go at some more practice problems. So the problem we've got here reads as follows. Huntington's disease is an inherited disorder which results in the lack of control over muscles and progressive mental deterioration to the point that sufferers are unable to look after themselves. Symptoms do not appear until the age of 35 to 40, by which time sufferers may have passed the gene for the disease onto their offspring, often unknowingly. Now, following on from our last lesson, I'm going to use some different colours to represent people of different generations. So, Susan Abbott, 40 years, has just developed the symptoms of Huntington's disease. Her father, of a different generation, Jim, is hospitalised with the disease, but her mother, Rebecca, does not have the disease. Susan's husband, so jumping back to my highlighter here for yellow, because Susan's husband, Peter, must be the same generation. Susan's brother, also of the same generation, Rob, 50 years, does not have the disease. Susan and Peter have 2 children, so I'll switch to a third colour now for my third generation. Susan and Peter's children are Helen, 21 years, and Martin, 25 years. Helen is married to Trevor. Helen in our blue generation, so I'll colour Heaven or colour Trevor in blue as well, and they have just had their first child, Dennis. A different generation once more. So if I was to order these, I can see now that, well, Susan's parents, Jim and Rebecca, are green, followed by Susan, Susan's children, Helen and Martin, and lastly, Susan's granddaughter, or grandson I should say, Dennis. So to start drawing my pedigree, we're going to look at the parents and we're going to see that Jim is older than Rebecca, so I am going to draw Jim first, so a male and female, and I can see that in the passage here, Jim is affected by this particular trait for Huntington, so we're going to shade Jim in here. The reason that we're going to shade Jim is that the question has asked us to indicate the person's having Huntington's disease by shading. So if I was to draw my key over on the right-hand side, I would be drawing something along the lines of this, where my individuals who are unshaded would be normal, unaffected by Huntington's, and those who are shaded have been affected by Huntington's disease. So moving on, we've done generation 1, tick. We're now going to have a look at Susan, Peter, and Rob. So when we look, Susan's brother Rob is 50, Susan herself is 40. So when we come down here, we have the 2 siblings, and of the 2 siblings, we're going to draw Rob first, as he is the eldest child, followed by Susan. Of the 2, we know that Rob does not have the disease, but Susan has just developed symptoms of Huntington's, so we will shade Susan in here. Now we know that Susan is married, and Susan's husband is Peter. And we're told in the passage that Peter's family has no history of Huntington's disease. As we follow down, we can now see Susan's children, which were Helen and Martin, Helen being 21 years and Martin 25, and this again tells us that we need to draw Martin first, as he is the eldest, followed by Helen. We are then told that Helen is married to Trevor, so we draw a line connecting Helen to her partner Trevor, and they have just had their first child. Of the first child, we know that it is a male, Dennis. So now that we've drawn our drawn our pedigree, we can now label our generations over on our left-hand side using Roman numerals, and following this, we can now label or number the individuals in each generation as well. Now, something that was key in this question up the very top in our first passage, which we've highlighted, is that symptoms do not appear until the age of 35 to 40. So in order for us to determine if this pedigree is dominant or recessive, first of all, we need to find some examples that we can use. Unfortunately, in this example, we won't be able to use any of the individuals below this yellow line because they are simply not old enough yet to show symptoms. So we're going to be looking for patterns in the first 2 generations. So if we start here with autosomal dominant traits, we can see that 2 affected parents have an unaffected child. Unfortunately, we just don't have enough information here because we don't have 2 affected parents. What we can see, though, is that every child has at least 1 affected parent, namely individual 2-2, or Susan, has an affected parent, her father. So it's looking likely that at this stage, this trait is dominant. If we then move over and we start to have a look at an autosomal recessive trait, we don't have any instance here of 2 unaffected parents, so we simply can't tell. But what we can see is that this trait does not skip a generation. Hence, it is unlikely at this stage to be an autosomal recessive trait. Lastly, we have a look at our sex-linked recessive traits, and in this instance, we need all females affected have an affected father, which in this case we do have. All sons from an affected mother must be affected. We can't tell this one just yet, but again, that is largely due to the fact that up the top, we've been told that Huntington's doesn't lead to any symptoms until the age of 35 or 40, and we usually have more males affected, which in this case, we do not. So based on this information, it's pretty safe for us to assume that this trait itself is dominant. So when we're writing the genotypes now for our individuals, a normal individual will be represented with a homozygous recessive allele, and in the case of those affected by Huntington's, they can either be homozygous dominant or a heterozygote. So now that we've drawn our pedigree and we've labelled it and we've made sure that we filled in all of our key criteria, I'm just going to remove my yellow line and my stack over on the left here. We're going to have a go at stating some of the potential genotypes of individuals. So before I can state the possible genotypes of Rebecca, Jim, Susan and Peter, I'm going to make it a little bit easier for myself. I'm going to assign each of these people a coordinate. So if I'm having a look up the top, I know that Rebecca comes from my first generation. Maybe we will keep the highlighting from earlier there. And Rebecca, 68 years, is our female in the first generation. So I can write for Rebecca, she comes from the first generation, followed by a dot, and Rebecca is individual 2 within that generation. Jim is her husband, again in the first generation, but this time individual 1. Susan comes from the second generation, so we're going to start by writing our Roman numeral for 2, followed by a full stop, and Susan is individual 2. Last, we have Peter, and Peter is Susan's husband, again coming from the second generation, and Peter is individual 3. So now that we have this information, I'll just zoom in a little bit here. We're asked to determine the genotypes, so the alleles for each of these individuals. Now, when we look at our normal individuals, namely Jim, individual 1.1, we know that the genotype for Jim is going to be homozygous recessive. And we know this as Huntington's, as we've determined, is a dominant or autosomal dominant mode of inheritance. We can also use this information to help us with Peter, individual 2.3, who is also unaffected, meaning that he will be homozygous recessive. Our difficulty comes now with determining the genotypes for Susan and Rebecca. You know what? I've done Jim and Rebecca the other way around. Rebecca is our unaffected individual in this instance, and Rebecca will be our homozygous recessive individual. So when we're trying to determine Jim and Susan, we can first roughly complete some unaffected individuals here. And we can see that in order for Rebecca and Jim to have produced both an affected and unaffected daughter, and knowing that Rebecca is homozygous recessive, we know that Jim must have both a copy of the recessive and dominant allele. We know this as Jim has to have passed the recessive allele onto his son, and Jim has to have passed the dominant allele onto his daughter. So Jim, therefore, will be a heterozygote. When we now have a look at Susan, now that we've determined that Jim was a heterozygote, we can also use Susan or Susan's mother, Rebecca, to see that Susan must have inherited at least one copy of the recessive allele. And because she's inherited one copy of the recessive allele, and we know that she's affected, she must have received the dominant allele from her father. As we move down, we're asked to determine the probability that Helen has inherited the disease. So we now need to find Helen on our graph, and we know that Helen is the female daughter of Susan. So this puts her in the third generation as individual 2. So just above Helen here, I'm going to write my third generation individual 2. Now, in order to determine the probability that Helen has been affected for this particular disease, we need to first state our phenotypes of Helen's parents. We know that Susan is an affected parent, and we know that Susan's partner, if we scroll up here, is Peter. And we know that Peter is unaffected for this particular trait. So we can write unaffected here. Fortunately, we've already determined our genotypes for Susan and Peter. We know that Susan is a heterozygote and Peter is a homozygous recessive individual. Using this, we can now draw our Punnett square. I'll switch back to my black pen here for a second, and we can see that Susan, if I write her alleles in up the top, and Peter over on the left-hand side, we are crossing our heterozygote and homozygous recessive individual, leading us to have two particular genotypes. So our genotypes for this are going to be 50% heterozygous and 50% homozygous recessive. This leads us to then have a look at our phenotypes, and we can see that in the case of those affected with the dominant allele, 50% will possess Huntington's disease and 50% will be unaffected by Huntington's disease. So we can finally say, now that we've done all of our working, determine the probability that Helen has inherited the disease. So therefore, there is a 50% chance Helen has inherited the disease. Oops. So, we have one final question left for this part here. And this question reads as follows. Determine the possibility that Dennis could inherit this disease, and key for this question is to explain. So what do we know so far? If we go back to our Punnett square, we know that Dennis is individual 4.1. So I'm going to include that information down here just above Dennis. Now, Dennis's parents are Helen, who we've just determined the likelihood of inheriting Huntington's disease for, and Helen is married to Trevor. So we can see that Trevor and Helen are both unaffected as yet, and unfortunately we don't know if Helen is infected because they are both below the age of 35 to 40. So what we do know, we know right now that there is a 50% chance that Helen has inherited the disease. And what we can use to support our information here is referencing the Punnett square that we've done in part C. So if you wanted to reference that in your response, you definitely could. Now, if Helen has inherited the disease, there is also a 50% chance that Dennis will inherit the disease. How do we know this? Well, we know that Helen is a heterozygote, and if I was to draw another Punnett square, it would very closely mimic the one that we've just done. If Helen is affected, Helen will be a heterozygote, and we know that her partner Trevor has no history of Huntington's. This leads us down the track of repeating our Punnett square from part C of our last question, where 50% of individuals will be affected. So, if Helen is affected, there is a 50% chance she will inherit the disease. So we now have two probabilities, and the easiest way for us to determine is to take our 50% probability, which I'll represent as 0.5, and we multiply that chance by the 50% chance that if she is affected, Dennis will inherit the disease, or 50% chance Dennis will inherit the disease, and this gives us a 0.25 probability, or a 25% chance that Dennis will inherit Huntington's.